Good morning to everyone. To thanks to everyone to giving me this opportunity. And here I am going to explain our internship project on embedded system. The project name is a washing machine simulation using PIC16F877A Microcontroller. Myself Vishal Kumar Pandey. I am currently graduating from the Mizoram University. It's a central university and BTech Electronics and Communication Department with a strong academic performance. And let's move to discuss about that's it of myself, and let's move forward to the project. And here the table of content, what type of things we are going to use in the next slide. First, introducing about the embedded system, what is embedded system in C, embedded system and its component, what is here some mistake I will correct after the making video. uh, what is the microcontroller, and this is the PIC microcontroller, software use, peripheral use, project demonstration, and finally, I will end it this slide with conclusion. And this is the introduction. This in today's modern world, automatic play a crucial role in improving efficiency and reducing human effort. Means day by day we want to make things feel easy. Then means if someone is working, uh, then they think then how to do this work very small, and how to consume the time. This is the main thing we are using day by day new technology. In the one of the most example, and we all are familiar with this example, washing machine. Day by day we are using the advanced technology to make the sort of many problems to do the making the washing machine. One such of example is washing machine, which has become a common household appliance that simplifies daily codes. To understand and replace the working of washing machine at a basic level, and making this washing machine, we are using embedded system with a microcontroller, and we are using this built using the PIC16F877A microcontroller chip we are using. This is the embedded system. Why C for embedded system? Why we use C for the embedded system? C is widely used in embedded programming due to its speed, probability, and in close hardware control. It's able to efficient to use of the system resource. Means C is the very basic or easy language which we can use in that embedded system. Then here we not know the more much things in the C. The same things we are studying in the programming the C. The same thing we are using here, and same path we are doing here follows to data type, variable, pointer, direct memory access, and things on. We are extra we can use here. Here control flow, decision making. Then control flow means your control flow and decision making. We say that the loop condition and logical structure are used to create program flow, react to hardware and user input. Means think first you think we are making a washing machine. We are working on a washing machine project. Then first we think what type of things we are using to make the washing machine easier, because everyone don't know about the technology, so we make them to usable to those who don't know about the technology. They can also use these things. This is the main control for decision making. Modular programming with function using preprocessor directivities. These things we can use. After that, embedded system. An embedded system is an integration of both hardware and software designed to perform a specific function or task within a large system. Means whatever things you have, that's make them is easier, because the embedded system we use software or hardware, both things we can use, and we can perform the design with function or task within a large system. Means embedded system is only using for the large system. We can also use in the short, but mainly people are using in the large for the large system. Common example of embedded system is like that smart TV, microwaves oven, robotics and automation system in aircraft, medical instrumentation like heart monitor machines, BP machines, and ultrasound, ultrasonic, these things, and smartwatch, fitness tracker, and other wearable touch. Uh, just forget about all things. Just think about the mobile phone. What is the mobile phone? Mobile phone is always walking your things on embedded system. Without embedded system, we cannot make further. We cannot move forward to the mobile phone. If you have mobile phone, then you think the mobile phone will make with embedded system, using embedded system. So move forward the next slide. Types of embedded system. There are types of embedded system. Embedded system having mainly two types: based on performance and functional requirement, and based performance on microcontroller. There are in the microcontroller there are three types: the small scale, medium scale, and spo- sophisticated. And this based on performance function requirement, there is a real time, standalone, network, mobile, these things. And here the embedded system and its component. Embedded system hardware component, these are firstly is we give the power supply, then microcontroller, this chip, PIC, these things, whatever we using these things, microcontroller we use here, then memory, then timer counter, then communication port, then input output port. These things in the hardware component are there. My let's we come to the microcontroller. What is microcontroller? Microcontroller is a complex integrated circuit that acts as a brain of embedded system. It consists the essential component of a small computer, including CPU, memory, input-output, timer, communication interface, ADC and DC. ADC means analog to digital converter. DAC matlab digital to analog converter. And communication interface, we use the UART, SPIC, I2C for data exchanging. Timer we can use to make the timer, like how much timer you want to fix to uh, wash your clothes and those things. Memory means RAM, ROM. Memory you can make the memory to store the data, how much time, how much things we can you want to put. This thing will memory will store. CPU is a basically central processing unit. This exerts the instruction. What type of instruction means what type of things you want to do, the CPU will work on these things. And what is PIC microcontroller? PIC stands for peripheral interface control, a family of microcontrollers developed in microchip technology. PIC microcontrollers are widely used in the embedded system because they are easy to program, cost effective, and support a wide range application. Some features of PIC, peripheral interface of controller in the microcontroller, we can know, and I will mention here. This is RISC architecture. Then PIC used for reduced instruction set computing, RISC architecture, and Harvested architecture. This is separate memory for instruction and data allows faster processing. Means that things will make to easier the program and the software. Multiple families. The PIC having the multiple families. Not I told you that PIC 16 these things we can use. Uh, Not these things will be directly used here. Look, I'll tell you one thing. Uh, where is this thing? Uh, yes, this PIC16F877A. This model we can use the microcontroller, but except that so many different families are there of this microcontroller. On chip peripheral including ADC, analog to digital converter, timer, PWM module, UART, SPIC, I2AC, etc. etc. Many things are there. uh, Flash memory. Program memory is reprogrammable, means flash memory we can use the reprogrammable memory. Means first you program, if you found any error, then you can reprogram this structure, suitable for developing and updates. Low power consumption, sleep modes and power saving features make it ideal and portable device. This thing will make the very awesome and interactive this device. Popular PIC microcontroller. These are the model name. PIC10F200. There it will consist 8 bits, and the feature is basic low pin out using the simple LED and control. But this all not these things, not this 1 2 3 4 5 6, not these 6 are the model is there in the microcontroller. More much model are there, but I will mention only 6, and these 6 we are using for our project, this PIC16F877A. This is 8-bit widely used rich peripherals and evidence system students project will very easily, that's why we are using here this. And basic internal block diagram of PIC microcontroller. First, flash ROM. Flash ROM matlab program memory. First we create one memory, then memory will send it to the CPU. Whatever data you are creating, whatever your data doing, then CPU will work on arithmetic logic ALU, means ALU the CPU core. The CPU will work, and the CPU will know the full instruction about the program. This is first in the timer. Timer is counter, and another is the data memory RAM. In the timer, we need to fix the time, how much time you want to do the means someone you want to give the 5 minutes to done the project, and not project 5 minutes, they want to after 5 minutes my washing machine will be automatically turn off. The timer will be working on that thing, and the memory will store the data, how much time they give, and after that they convert this analog to digital converter module, then input output port, and the communication part is working on these things. Program tools for PIC. These are program tools. These full are Proteus, PIC Simulation Lab, PCAT, and XC8 and the XC32 compiler, MPLAB and X IDE. These are the program lab, but we are using mainly here MATLAB X IDE, official development environment by Microchip, and Proteus PIC Simulation Lab, where we can simulate the data, whatever code in the MATLAB we do the coding, and after that Proteus we done the simulation part. And the peripheral use CLCD, interrupt, and timer, and tactile switches as a digital keyboard. We are going to explain this for the more the next slide. This is CLCD. A, this firstly we know about that CLCD means what is this CLCD? This is the character LCD. Is display module used to show alphanumerical characters. Common types are 16 to 2 bits and 20 to 4 bits extra, meaning 16 characters per line and 2 lines, or 60, or not tell them there's 20 characters and 4 lines. Here the CLCD pin will be mentioned. I will mention this in this figure. This is RS, E, D, D0, D1, A24. These things means up to the D0 to D7. Here VEE. V is the constant control. It's a voltage part. RS register select. RW read write. E enable. D0 to D7. This is the data pins. Means here we can give the input. VSS and VDD power supply. This thing is interrupt, and the interrupt is a signal of the microcontroller is temporary stop and the main program and jump to a specific interrupt service routing ISR to handle urgent tasks. This interrupt jump to the, if any error is found, is directly jump to the next part and return to the main program. They are having the two main parts, external and internal. Timer. We know about the timer. Timer will basically fix the time, how much time you want to, after how much time the washing machine will automatically turn off. These things we can mention here, and I will explain about that whatever I will written here. A timer is a peripheral in a microcontroller used to measure time or journey delay. It counts clock pulse and triggered events like interrupt. When a certain count is reached, block diagram of a timer explanation is a clock, per scale, timer, compare, and overflow. Then pre-scale is only slow down the clock. If clock speed is very high, it will make a minimize and send it to the timer. A timer will send to the overflow. And used for creating delays, generating PWM, and measuring input signal. This is the tactile switches as a digital keypad. Now you can see in your washing machine, and Many where the things will be coming, the directly is this keypad type things will be coming in the new type of technology in the washing machine. These tactile switches are physical button that acts as a digital input. When passes a set of that can be form a digital keyboard for input. Like this input in the written is 0 to 9. This total 10 numbers are there, and some special characters are there. Whatever characters is present in your phone keypad, the same thing we can put it here. The working of that row are output and columns are input. Okay, row are output and columns are input. That here we I will make for that 4:3 microcontroller tactile switches as a digital keyboard. This microcontroller scan the row and read column to detect which key is pressed. This thing after that this is the block diagram where my project will be working. This working of washing machine. Keypad inputs RB3 of a scaling mode. This section RB is turn off to start R5. The pushing washing machine. This is the microcontroller chip. Timer 2 module, the cycle control, and CLCD 16 into 2 display. Show the mode, and this is LED fan, and this is a buzzer. And after that we move on to the simulation part. Uh, Now the time to explain the simulation part, and the simulation part will be basically this is the code where we can make the header file and the source file, and the source file and header file we make the build and run, and after that we check the code, the building will be done. And here is to give the time. Yes, total time is 3 seconds. The build is successfully. If you want to do the build, just go to the hammer part and just tap to build. The your code will be built, and here the hex file will be already generated. If not generated, you can go through the hammer part and try to build your hex file. And after that building the hex file, you want to come to the your PICSIMLAB, and after that PICSIMLAB you are coming. Then now you will start doing your experiment. Just upload the hex file. Wait for a few minutes to upload. The hex file will uploading, and after hex file will uploaded, we can move forward. Yeah, this is uploaded. Press key 5 to on power on the machine. Just press the 5. Yes, look, the machine will be started. Washing machine will be started. And here look, the washing machine is programmed, is showing the daily and heavy and dedicated power. And this is the LED button is showing the movement of this machine, and what is done by this machine and washing machine is this daily and heavy dedicated things. And this is the program heavy dedicated whites, means different type of features are there. What type of things you want to use, you can watch for your different clothes. Okay, stain watch, eco cottons, and this bed sheet, woolens, and rain plus dry. Many things you can use, and many things also you can want to do. Then you can do the project and you can add. And after that we can next done the water level. Let me done the water level. Yes, water level. This is auto, low, medium, and the max. Auto means it automatically fix whatever how much water is needed for the clothes. It automatically fix. And after the certain amount of the water, it will turn off. Low means low, it will high and max. On the medium, like it will giving a medium level of water. One is high and another is maximum. Then these things auto will be good for the machine. And after that, this SW5, this button is for start button, and 6 is for stop button the machine. Yes, this is, and this, and the LED is also showing the working of this thing. And the buzzer will be on when the timer will be up. Yes, program is heavy. We can give the time is 55 seconds. Let's wait for 55 seconds and the program will work. Just wait for. Let me check why it stopped. Yeah, it's working. Now the machine will be hit. So we can start the fan to cool the machine. Okay, 32, 31. Now just time begin will be stress 26, 24, 3, 2, 20, 90, 80, 70, 60. Spin 6 and 3, 2, 1. Yes, the program is completed and the buzzer will now turn on, so you can remove your clothes. These are the function of this. Uh, these are the function or whatever function is working on your washing machine. The same things is showing in the PICSIMLAB, and again the buzzer will on. We can you can turn off, and after the same thing will be doing. Let's move to the conclusion. Finally, we discussed the last part of the project, that is conclusion. In this project, firstly I will explain my demonstration project about that, regarding what things we use to making the washing machine and what type of things, and already I done my simulation part, and now the conclusion part is the project is successfully demonstrated the simulation of the basic washing machine using the microcontroller part, that is PIC16F877A. That is the part of the microcontroller, is the not a I will not told that this is the main part. It's the means major part, or we say that a part of that microcontroller. By interacting peripherals like timer 2, interrupts, push button, and 16:2 LCD, then the system effectively automatic washing machine operating is the rising, spinning, and draining. So many things are there. And finally, through this implementation, we have so the microcontroller can be used with the real time processing the embedded system. And the project is not only dependent of understanding of microcontroller programming. This is the peripheral interface, but let the function more advanced and automatic application in the future. We can elaborate and design different type of also washing machine to what of technology will came and what technology the people want to use. Thank you.